I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing energy bar charts and writing conservation equations when there's objects working on a system. All right, so in this situation, when we're drawing our energy bar chart, we have a very common situation that is a very common lab that helps us determine Hooke's law. So you have a spring that is stretched from equilibrium to a distance of 1 meter. Now, I don't suggest you stretch any of your physics teacher springs to 1 meter because you'll most likely overstretch them and you'll end up with a very unhappy physics teacher. So when we're talking about this situation, we're not going to stretch any of your physics teacher springs 1 meter, maybe some other distance. All right. So again, a bar chart's just a qualitative representation. So we're looking at the initial situation, the energy flow, and the final situation. So the first thing to do is define the system. So the system consists of anything that could have mechanical energy. So in the situation, mechanical energy, a spring could have mechanical energy. The earth could have supply gravitational energy. If the spring is stretched and it's up on a counter, we're going to assume that the counter has a height of 0 for simplicity's sake, since the height of the spring is not going to change. So in the system, we're going to have the spring and the earth. Now, in the initial situation, we're going to ask ourselves the three questions that we ask each time, the three types of mechanical energy. Is there a height greater than 0? Well, we define the counter as a height of 0, so no. Is there a spring stretched or compressed? Well, in the initial situation, it's not stretched, it's at its equilibrium point. And lastly, is there anything moving? Well, no, the spring's not moving yet. So wait, we don't have any energy in the initial situation? What does that mean? Well, that means there has to be something that is working on the system. So somebody had their hand and was pulling the spring, so the hand is outside the system, and the hand is transferring energy into the system, transferring it directly to the spring. Which means in the final situation, we still don't have anything that has a height greater than 0. We still don't have anything that is moving because the spring, as it was being stretched, it stopped stretching at 1 meter. Again, don't stretch your physics teacher springs 1 meter. You'll get in trouble. And lastly, we have stored spring energy because the spring is stretched. So in the final situation, we have stored spring energy. So what does our conservation equation look like if we have nothing in the initial? Well, because we have this object, this hand, transferring energy from outside in, what that tells us is that there's something that is working on the system. When you have an object that is working on the system, transferring energy from outside into the system, that means that W value is not going to be 0 in this case. So our conservation equation is going to look like this, that the work is equal to the stored spring energy. So the hand had to apply enough force to move the spring and stretch it that 1 meter, so that the work is equal to the stored spring energy. All right, so here is another situation that we're going to draw a bar chart for. And that is a car rolling up a hill, and it has friction, and it rolls to a stop at the top of the hill. So we're going to start with our blank bar chart, and we have the initial situation, we have our energy flow diagram, and final situation. So we're going to discuss the situation where we have only, again, mechanical energy in the system. So what do we have? Well, we have the car is moving, so that's a mechanical energy, that's kinetic energy. It's going up a hill, so we're going to have the earth. So in our system, we're going to have the car and the earth. So then we're going to go to our initial situation, and we're going to determine, okay, what type of mechanical energy do we have? So is there anything moving? Yes, the car's moving. Is there anything that has a height greater than 0? No, the car hasn't started going up a hill. Do we have a spring that's stretched or compressed? Well, we don't even have a spring in this situation. So the only thing we have is kinetic energy. So from the kinetic energy, we know that the energy is being transferred from the car to the earth because it's rolling to a stop. But we also have friction in this situation. So the car transfers some of its energy to the earth, but it also transfers energy to another place. Well, it's transferring it to the surface. So the hill, the energy is being transferred from the car to the hill. So this is an example of an object that is working on the system that is removing energy from the system. So what that tells me is that the initial situation has to have more energy than the final situation. So at the final situation, the car is no longer moving. It is higher up in the air, so that means we have gravitational energy. And again, there's no spring involved in the situation. So we only have one type of energy, and the energy amount has to be less because there is energy transferred out of the system. So again, this is a qualitative representation. So the fact that I drew 4 bars for kinetic and 2 for UG is just a qualitative. It just matters that kinetic is more than UG in the final situation. All right, so the important part is getting that conservation equation. So the conservation equation, again, remember, is kinetic energy, the initial situation, plus any work, which in this case, the work is coming out of the system, and that's going to equal the final situation. So how do we represent the work, the object working on the system removing energy? Well, we're going to write that as minus W. So we're going to have the kinetic energy minus W is equal to the gravitational energy. And that is how you're going to take into account working on systems, whether it's energy going in when we are pulling the spring or energy coming out through friction. I hope you found this video helpful, and I hope you all have a great day and an even better tomorrow. If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.